Hi everyone, welcome back to the workshop, and it's repair time again. And in my last video I repaired this Digimess DC power supply. As you'll remember, it's a switch mode power supply. Eventually got to the bottom of it and got it repaired. So I found another power supply on eBay, and this is it here. It's I can't even pronounce that. It's a Huzco or something like that. It's really a bit unpronounceable. I'll zoom in a minute and let you have a look. And if you compare the two power supplies, they're actually pretty similar looking, but I suspect they're completely different inside. They're almost the same size and shape, buttons in the same place, so wherever they're getting, these people are getting their cases from, or their front panels, there must be a pretty common supplier for these sorts of things. The one I'm repairing today is slightly longer. It is a different case, it's not an identical case, but there's a big difference between these two power supplies. You remember the original one that I repaired last time was a switch mode power supply. This one's a linear power supply. I don't know nothing about it whatsoever, but I reckon it's linear just by the sheer weight. This has got a transformer inside of it, and it was advertised as faulty on eBay, so I just thought I'd pick it up. Let's see if I can repair it. You know how I like repairing power supplies. It does power up apparently, but you can't set voltages or something like that, it said in the ad. I'm not too sure. So let's take a look. So this is it. This is Huzco, or however you pronounce that, an APS 3005D DC power supply. Now it doesn't exactly say what the specs are of this power supply, but I'm suspecting the 30 is for the 0 to 30 volt and the 5 is for the 5 amp rating. There is a little instruction manual that comes with it that kind of covers the whole series of power supplies, but actually it doesn't really tell you much in it at all. It mentions the 30 volts, but that's about it. It doesn't mention much else, and of course it tells you how to use it and what the knobs do and all the rest of it, but I don't think we'll need that. So let's get it powered up and let's see what it does. Right, that's the power cord hooked in. It is set for 240 volts. It was bought from the UK. So let's get the power going here. Well, at least it powers up. There's a slight hum, I can hear that coming from the transformer inside. So let's have a look at the coarse and fine. Haha, there's the fault. It just seems to be stuck at 0.5 volt or down at the bottom end. It's the voltage adjust coarse potentiometer is doing absolutely nothing. So whilst it's at that voltage, let me get a multimeter going. Let's grab one here and let's see if we're actually getting anything out. Well, we're getting -2 volts on the output there. Wow, and the ports are doing absolutely nothing. Yeah, so there's definitely a problem there. Now, I don't actually have a schematic for this power supply. I have raked high and low on the net, and all I've managed to do is pick up some bits and pieces here from various power supplies that may or may not be related to this model or similar. So we'll kind of have to use this bits and pieces that I've got here in order to see if we can effect a repair of this power supply, or we might get somewhere just by having a good old look. Maybe there's something simple inside that we can fix. So let's get the case off and let's have a look. Now, I don't know if the previous owner of this power supply had a look inside it at all or tried to repair it. I've got no idea. Well, assuming that he didn't. So that's the case off. First things first, it is a heavy thing as I mentioned earlier. Here's the big transformer in the middle there. Not really got a label on it as such, so I can't really tell the specs. But we've got the primary coming in the bottom there, by the looks of it. Yeah, that's attached to the switch, sorry, the IEC input on the back there, and off to the power switch on the front. And we've got some secondaries up on the top here, and also at the other side there. I suspect that these are higher current secondaries at this side as opposed to that side, just going by the gauge of the wire used. And off to the back here we've got a nice big fan. We've got a heatsink mounted in front of it with a bridge rectifier, the main bridge rectifier by the looks of it, mounted on the top. And we've got a couple of transistors down on one side of the heatsink there. There's a couple of feed resistors, looks like big 5 or 10 watt packages there. And we've also got, which I think's probably some kind of thermistor or something like that, mounted on the heatsink as well, and one side of it goes away off to the fan in the back, so that'll probably be the temperature control for the fan by the looks of it. Over at this end of the power supply we've got the main control board, and of course the display board up on the back there. So we'll see if I can't probe around and see if we can find out what's going on. You know, I was just away to start probing around. I just sort of reorientated the power supply. I had a quick look myself, moving some wires around, having a quick look, fingering around about the PCB, that sort of thing. And look. .5 all the way up to 31.4 volts. It seems to be working now. Well, I'm definitely getting something on the display. So let me just put that down there, and got a multimeter onto the front of it. Let's see what happens. Let's go into DC there. Yep, and I'm 9.8 on the front panel, and I'm getting 9.8 over there on the multimeter. So right down 2.5 volts. Oh, meter helps if the meter probes are around the right way, but there we go. So 31.5, 31.6 on the multimeter and all the way down. So it's doing something now, so that's a fine control. Let me set it to 15 volts, so yep, the fine control's working as well. And if I just adjust the current control, well, it's not, I'm half thinking there if I screwed the pots all the way to the left there, it might start limiting the output voltage. I'll just bring it back up and just take another look at that. So I was half thinking there if I wait a minute, look at this. The output voltage is dying away. What caused that? There we are, I've got the voltage pots all the way up. I'm in constant voltage mode because the little LED here is on, as opposed to the CC mode at the other side there. It's off, but I shook the power supply there, and the output went shooting all the way back up to 30 odd volts, and I heard some switching on the relays. There's a couple of relays on the main control board there. I'll just zoom in, take a look at that. So there's the main control board there. We've got this is the bridge rectifier wire in here. We've got a couple of relays there. We've got a multi-tapped transformer here, and obviously depending on what voltage you are asking from the power supply, it's going to switch to different tap-ins on the transformer there. And when I shook the power supply there, as well as the display jumping back up, I heard the relays clicking. So there's something, dry joint, bad wire, who knows. Let's see if I can make it do it again. Bear in mind power is on. mean, it could be anything. It could be an electronic fault on the circuit board. It could be a transformer with a bad winding, intermittent, that sort of thing. So let me just get a soft-handled screwdriver here and see if we can get it to do it again. It's outputting 15.2 volts at the moment on the front of the power supply. Can't seem to make it do anything again, so just probing around on the circuit board here. I'm suspecting there's a dry joint or a bad joint on the board somewhere. I'm hoping anyway. I'll take a look down in the control board. There are some bits and pieces we can take a look at just out of interest. So this is obviously the main bulk cap here for the unregulated output from the bridge rectifier. Like I said, we've got a couple of relays there. That'll be for the switching the tappings on the transformer. We've got a IC down in the middle there. That's probably a quad op amp or something like that, or perhaps even a power supply control chip of some description. Not sure. I think that's a transistor or a regulator there. Some more capacitors with a current shunt down there. It's just a bit of wire wound up and is soldered onto the power supply there. Got another bridge rectifier here. I suspect that's for, there'll be an extra tapping on the power supply, on the transformer, sorry, just to provide some power for the board itself, the control board itself. So that bridge rectifier down there is probably for that. That'll be working because we've got a display on the front. But so far, I can't seem to get it to fail again. The fan at the back's off at the moment. Well, that's to be expected given that I'm not really drawing any current from the power supply yet. I'm just probing around here. I can't get it to fail again. In fact, you can hear the relays clicking as I increase the or decrease the voltage asked of the power supply. You can hear it, the relays clicking. So I'm right down at the moment at 2.5 volts or so. I'll just wind it up slowly. Yep. So the first relay clicks at about 5 volts. And another one again at 20 volts. Could be a sticking relay. Right, so we're getting about 14 volts AC on the feed to the bridge rectifier, but I'm getting nothing back at all. The solder joints at the circuit board look fine, but I just thought I heard something when I was wiggling these wires here on the terminals at the bridge rectifier itself. So I think I'll put the power off, and I think I'll pull back in this sleeve in here at the bridge rectifier and see what we've got. That's the power off. Right. Power back on, and it's still in its failure mode. So let's go on and check the AC. Let's get the meter in a good position. There. Check the AC at the bridge rectifier. .14 volts AC. now the output. 18 volts DC there, and it's still in its failure mode. So let me just turn the power supply over again. And measure out the circuit board again. So outside terminals. (18 volts DC). That's working now. And there is the problem. Well, I'm hoping that's the problem anyway. I was just wiggling the wires there on the bridge rectifier itself, and sorry, the lighting's not too great there, is it? And I just pulled off one of these wires here, just straight out of the sleeving on the bridge rectifier itself. So that's got to be the problem. So let's resolder that back on. I'll check the other ones as well. I think I've got long enough wires here. I think I'll cut them all short and resolder them back on with some new sleeving onto the bridge rectifier itself. So I'll go away and do that right now. Well, now there's a thing. So I just loosened the nuts, or took off the nuts in the front of the power supply there for the knobs, because that's what's holding the board in there. It's held on on the front panel nuts, and I was just pulling the board out through no force whatsoever, and look at this. The pot is just broken away. It was actually, it looks like it was already broken, and you can see the remains of it are on the circuit board down there. If I just zoom in, you can sort of see there. So I suspect that's the problem. It's possibly these two pots are in series or something like that. And with this one being broken, it's basically the current control is just basically disabled there. So I will check the other ones, but now let's have a look and see if I've got one of these in stock and replace the one on the board. And there you go, that's it off the board. Now, you don't really often see this, maybe in a bad design where somebody's put too much stress. But normally, if you know something like this, you would break the legs off, go through the circuit board. You wouldn't really break it on the actual potentiometer sub-assembly there, but well, there you go. Well, raking through my stock, I don't have a 1K pot, but I do have a 5K pot, and it's actually dual gang. But if I cut off the rear gang, I think I can make use of it there. It's the same size, and it should just fit on no problem. A little bit shorter here, but I don't think that will cause too much of a problem. So let's get this one in place. 5K might make a little bit of a difference. It is on the fine control, so not really that bothered about it. So let's get this one fitted. Okay, we've got power back on again. I haven't put the nuts and the knobs back on yet, so I just want to give it a little test here. So we've got power back on, dynamic DC electronic loads off at the moment. So let's turn it on. I've got it set to 5 amps again. So there we go, 5 amps at 24 volts. So now if I just screw down the course control to adjust the, and there we go, we've got CC mode light, and we're now limiting the current, and of course the voltage has dropped away, so I should be able to screw that right down to its minimum, which is 0 amps. Of course the fine control is probably not going to be as fine as it was, unless I change out that 5K for a 1K more than likely, but it is actually working there. It's I wouldn't actually say it's much finer control than the course adjust, to be honest with you. Well, yeah, I suppose it is at the upper ranges. and I just heard the fan kick in there. I'm obviously generating a bit of heat and that fan's kicked in. So yeah, I'm happy with that at the moment, so I'll screw it back up to its 5 amp limit there, which is obviously just above the set point there, and it's allowing the 24 volts. So I think we've got a good old repair there, so let's get our box back up. So there we go, power supply's back together again and it's working, everything back together. CC mode's working, CV mode's working. A nice little power supply from the workshop, I like it. How noisy it is, anything like that, I couldn't really care less. I haven't really measured any of that, but for charging batteries, all that kind of thing, I think it may be alright. So thanks for watching.